Hello, everyone. It is 1 past 12, and I would like to welcome everyone to this week's MIU. My name is Mert Yıldız, and I will be the moderator of this session. Today, I have here with me my colleague Ricardo Suarez, an expert on ship motion modeling, and he will be presenting about how artificial intelligence can be used to enhance system identification for surface and underwater vehicles. Before moving on with the presentation, let me remind you that this session will be recorded, so I ask everyone to keep their microphones and cameras off during the presentation. And if you happen to have any questions, feel free to write them to the chat, and they will be answered at the end of the presentation. Ricardo, floor is yours.
Thank you very much, Mar, for your introduction, and thank you everyone for assisting to this presentation. Well, today I'm going to talk about the improvement in system identification for surface and underwater vehicles based on artificial intelligence algorithms. Let me start asking, why is system identification so important in the maritime industry? Well, system identification was started implemented from the 60s in many areas of the industry, like automobile, aircraft, and obviously maritime industry and others. For system identification in a specific maritime industry has a strong impact in the last years. And here, for example, we can see one of the areas that are most system identification is implemented, but this is only three of many that normally we implement in the ship. Nowadays, system identification is not really a topic that is closed, if not is open. And we can say that with the appearance of artificial intelligence and machine learning algorithms, system identification is gonna suffer a high improvement in their performance. And especially in the ship, we consider that artificial intelligence are gonna help us to have a better understanding about the dynamics of the ship, that in this case will allow us to have a better understanding about the maneuvers and in different states. This means we are going to achieve to get better, not only better trajectories, also to get a better use, a reduce of the fuel consumptions of the ship and reductions of the CO2 emissions due to carry out some efficient and optimal maneuvers. And with these two performance efficiencies, we are also going and enhancing safety due to that we can carry out we can predict maneuvers under different scenarios to know which is the real situation and obtain the better maneuver in the safety way. And also system identification, machine learning implementing system identification allow us to design new advanced control system, for example, for autopilots for prediction of the parameters. Well, let me talk a bit about which is the current state of system identification for ship and submarines. We will say that system identification in all areas is basically determination of the model structure and parameter prediction. But I will say that determination of model structure in case of the shipping industry is really not, in this moment in research, is not our main challenge. Because from the point of view of the simulation, the mathematical model that we implement for computation of the system outputs through the numerical integrations, this kind of mathematical model are very well known and very well studied. This means that from the point of view of the mathematical model, we can divide in a structural part and parameter part and part. The structural part, as I said, is very well known. The challenge for us nowadays is the identification of the parameters, because really they provide us the hydrodynamic behavior of the vehicles. As I say, the quantification of the weight parameter is very important for us in our research. And here a small example to see how is the influence of this hydrodynamic force that involves that the ship are involved in different conditions. Here is only an example of the tanker vessel uh, for a speed of 10 knots and rudder angle of 35 degrees. And we can see here in the right side in the picture that we have a factor that is relation between the depth of the sea and the draft of the ship, meaning that this parameter is 10 to infinity. We are talking about deep water condition, and when we are talking about this term 1.5 and 1.2, we are referring to shallow water effect. As we can see, for the same speed, for the same rudder angle, we can see that the performance of the ship is very different. We can see that almost between the deep water and 1.2 is almost the double of the trajectory produced at the same condition. This means show the strong impact that the hydrodynamic force has in the ship. The thing is, for us, it's important to know nowadays in the shipping industry, we manage a set of parameters. We say the navigation system only have a set of parameters for deep water condition, and when they move to shallow water condition, they use correction factors that are going to be implemented. But the thing, this is like a static picture. In reality, the ship has not only one loading condition, has different loading conditions. The ship operates in different trims and drafts. This means that this set of hydrodynamic coefficients are not showing the reality at all. This means with the help of the artificial intelligence and using the current methods, we consider that we could be able to predict hydrodynamic coefficients not only for one set, not for the many sets for the different conditions that the ship are involved. Here, I would like to show you, according to International Towing Tank Conference, which are the main the main methodology that we implement to get prediction of the parameters. One of the most important experimental methods. For example, here in Hamburg, we have one of the most important centers in towing tank, the HSVA. In this center, we carry out analysis, but unfortunately, they are very expensive and they consume very time. Sometimes the shipping companies really they want to spend they are react to use this analysis because especially for this very expensive and they take a lot of time. But I have to say that now towing times they use not only experimental methods, if not also use computational fluid dynamics. That these numerical methods produce a very good results, and this means reduce the time that we need to use the experimental time. But unfortunately, computational fluid dynamic methods at this moment they need to resolve for the mathematical model need to solve for partial differential equation. What does this mean? That the computation time is very expensive, and maybe to carry out some simulations, we need to wait like 20 or a bit more days to get some result. What does this mean? That the way that the system identification implementing with this mathematical model are not the best option for real-time tools. In this case, the other option is system-based maneuver simulation method. That is mainly what we are implementing in the Institute of Fraunhofer for research in system identification. And what we are doing is collecting data from this towing tank and from CFD, training the algorithms, and produce the prediction of the parameters and information from this. But as we will see now, also we can use real data to predict this hydrodynamic coefficients. Let me continue. Here, as I said before, the implementation of machine learning in comparison with the conventional algorithm that we are using nowadays in the system identification are producing better results. The first, most important, obviously, the important step in machine learning implementation is the gathering the data. As you can see, the data that we can get is from IS data, gyroscope from the ships, and also from the towing tanks, and also, as I said before, from computational fluid dynamics. Also stop here and say, relating to computational fluid dynamics, that nowadays the implementation of artificial intelligence are serving to reduce the number of tests that we need to carry out in CFD. And this is due to the with a small number of tests, we can get the data provided by them, training our algorithms, and do predictions in terms of minutes after the training the algorithm. This means that in consider for the future CFD, it looks like from the other three, one of the most important tools to gather data, because the uncertainty nowadays is less than ever, and this can be very useful for training the algorithms without necessity to use real data. Here, only example of how is the process to training the algorithms. We gather the data with training. We look for the optimal algorithms in offline, for example. And one time that we get the optimum ones, we implement in the system of the chip. But I will say that at this moment in Fraunhofer, we are focused in this algorithm that don't require too much data for training. This means that with nowadays we are getting good results only using not too much data, maybe 1 or 200 kilobytes files of data, and this is enough for training our algorithms and get a good predictions. Also mentioned that in the rates that we are getting this, we are working with the algorithms is in the supervised learning. This means that we have labeled the data and we are moving in the regression to get these parameters. And here, to conclude this presentation, I would like to show you some of the results. Unfortunately, reality and tests are not always like this, that we get this good result. Unfortunately, we have to face nowadays some problems with the algorithms, because sometimes, especially because the algorithm has to provide a solution not only from the point of view of the mathematical point of view, if not also from the point of view of the physics, to have a good understanding about the performance of the chip. And let me put an example here. We have the second order term relating to the longitudinal velocity. Normally, from the point of view of the physics, this coefficient is relating with the resistance of the chip. And the resistance of the chip is related to this coefficient because it's proportional to the square of the velocity, in this case, mu squared. As we see, the prediction is correct in this case, and the sign and the magnitude of the parameter coincide with the original value. And this is fine. But sometimes when we training our algorithms and we do predictions, sometimes in some case, we saw that the parameter of time produced the expected output in comparison with the original one. But the parameter has different magnitude and different sign. This means that the algorithm is providing a correct mathematical answer, but not a correct physical answer. This means that the algorithm has to fulfill both requirements. Well, if we are able in the future to predict and to create a robust model, I think the possibilities are amazing for the future. Because, for example, Seafarer and Captain can decide which is the best configuration for the ship. We can imagine that the ship, as I said before, is not always sailing with the same loading condition, and don't sailing always with the same draft or with the same trip. This means the parameters should be different. If we can predict in real time, captains in the future can have a navigation tool that help them to decide in real time, which is the optimum maneuver. This means that facilitate not only performance, efficiency, and safety. Well, I hope you consider this interesting at me, and I think I finished my presentation.
Thank you very much, Ricardo. It was quite interesting to see about how machine learning can be used for the system identification or to detect the parameters of ship motion modeling. And from the audience, if anybody have questions, they can directly write it to the chat, or they can simply unmute themselves to ask the question with a microphone. And in the meantime, I have a question. I wanted to ask, in your opinion, what would be the advantages of using machine learning over conventional methodologies?
Yeah, thank you very much for your question. Well, at this moment, we consider that the artificial intelligence and machine learning algorithms, in comparison with the conventional ones, bring with them series of restrictions and factors that, for example, improve in linear regression the conventional ones. For example, some of the algorithms that are implemented, one of the constraints is that in the regression, they implement some penalty factor to the outliers. And also they don't use some kind of parameter that they are such a kind of threshold. This means that the algorithms assume some kind of error. And this is something that made them very, very interesting. Also, I will say that definitely the performance of the regression is much better and robust in comparison with the conventional ones. Yes.
Understood. Thank you very much. And we have a question in the chat from Sebastian. Is there already a paper which presents the method and the results?
Well, at this moment, I'm working to write two papers now with the Technical University of Hamburg. But you can find nowadays, I will say it's a hot topic you can consult because there are many publications about this system identification for parameter prediction. Yeah, but I could provide you, or mail or you send me, I can provide you some interesting paper about this topic for sure.
I guess there is no follow-up question. And if there are no further questions, I would like to conclude this week's MIU. And I want to remind you, the audience, again, that you can use the link that I just posted to the chat for signing up for the future MIUs. And thank you all for joining. And thank you, Ricardo, for the presentation. Have a nice weekend.
Thank you very much. Bye-bye.
Bye bye.
Thank you, Ricardo.
Thank you.